Okay, so we're on 8.2. You can flip to that in your book. Perimeter and area of composite figures. A composite figure just means it's built from more than one figure, more than one type of figure. So a composite hockey stick isn't just made of wood. It's not just made of graphite or just made of carbon fiber. It's put together using different materials. Okay, anything that's composite is like a man-made something or other. It's put together using different things. Same with a composite figure. You can see your first diagram there. It's not just a rectangle. It's not just a trapezoid, but the trapezoid is built from a rectangle and two triangles. Okay, we already know the formula for the area of a rectangle and the formula for the area of a triangle, so we can use that information and put it together. We can composite it in order to find the area of this figure. So first, a bunch of helpful area formulas. What is the area formula for a triangle? The area means the space that it takes up. 1/2 BH. Okay? You can do area of a triangle is a helpful way to do it. Okay? The next one is a rectangle. The area, the space that takes up a rectangle. How can we do that? Area of a rectangle is simply length times width. What about a trapezoid? This one's a little bit tougher.
Wait.
We have done it.
Side, base,
You have to draw a line.
base
You
times
have to
height,
make it a rectangle.
base times
So you can make this a rectangle by
Then do this
cutting
outside.
off this thing and putting it over there. But actually, in some trapezoids that doesn't work, because I might have a trapezoid that looks like that, and then all of a sudden this triangle doesn't fit there at all, does it? So that's not the way to do it. What we need to do is
divided by 2.
take our two bases and find the average of our two bases, because that will give us the length here. Okay, so we take the area of our trap equals A plus B divided by 2, and then we need to multiply that by the height.
Oh.
Okay? Just take the average of your bases and multiply by the height. It's basically dealing with it like a rectangle, but in order to find the length of the rectangle, you first need the average of your bases. Okay? And the last one that you have there is a circle. What's the area of a circle? Yeah, we've got, if we have a radius there, then you have area of a circle equals, this is not a good way to do it, is pi r squared. Alright, so there's the tools that we have in our toolkit. Now it's time to do some solving, do some calculating. So right into example 1. Example 1, you have a diagram there. Diagram looks something like this. Okay, where this is 12 centimeters, this is 24 centimeters. The base of this triangle is 4 centimeters, and the height of the whole thing is 16 centimeters. Okay, so how are we going to determine the area of this figure, this composite figure? What are we going to do?
We need to do two different. We need to do 24.
Can we do two different or three different?
You have to do 3 different sets.
Yeah, let's do 3 different sections, okay? So there's 2 kind of ways to do it. You could just solve for this side and this area, and then solve for this area, and then solve for this area, and then add them all together. Or you could write a long math sentence that says, okay, I'm going to add this one, and this one. Okay? Let's break it up totally separately first. So a little note, in order to calculate the area of the composite figure, in order to calculate the area of the composite figure, comma, add the area of each part. Alright, so first let's deal with the area of the rectangle. So in order to keep your work nice and neat and organized, you use capital A for area, and then you have a subscript. So down in the subscript you have rectangle. Okay, that's telling you it's the area of the rectangle. Now what if you want, like if you want to just write it like this?
Yeah.
You can do that in this case. I would say that's fine, yeah. And then if
How
you
about
did
on
like the
text?
area of triangle 1 and then the
Yeah.
area of triangle
Instead of
2,
writing it out.
Can we label
I'd be
that?
fine with that. Okay, whatever. If you want to label these spaces,
A1,
A1, A2, A3.
Yeah, that's what we do.
uh,
That's how we learned it.
yeah, sure, as long as it's very clearly labeled. Okay? So if you're going to do that on test, make sure you actually have a diagram that says A1, A2, A3. Okay?
That's how we
Or
learned it.
A1 in the middle. But anyway, I'm going to do the area of the rectangle. What's the area formula for the area of a rectangle? Length times width. In this case, do we know L and W?
Yes.
We do. What are they?
16 and 24.
16 and 24. And if we put that in our calculator, we get... Of course, everybody has their calculator out and they're all punching in numbers to make sure they know how to do it.
300
We got 384, and it's measured in centimeters squared because it's area. Excellent. Let's take a look at triangle number 1. And over here, triangle number 2. Okay. The area of triangle number 1. What's the general formula for the area of a triangle? 1/2 base times height. Do I have the base and height of triangle number 1?
Yes.
I sure do. What are they?
16
The base is 12, the height is 16. And somebody's punching that into your calculator. The best way to do that would be 12 times 16 divided by 2. Or just 12 times 8.
96.
And it's measured in centimeters squared. Excellent. Go ahead and try the last triangle on your own.
Thank you. When will it be cubed?
Volume. Another dimension. Length times width times height.
And then at the end, we just add them all together, and that's
And don't we do A2, like area?
total area.
Sure, that's a good way to do it. So here we go. Let's do it this way. Sure, area total
Is 500.
equals, and I'm going to write the whole original, guys. I'm going to write area of the rectangle plus area of triangle 1 plus the area of triangle 2. And then we'll write in what we got for each of those things. 384 plus 96 plus 32 for a grand total of 512 centimeters squared, or squared centimeters. Alright, that was one way to do it. We're going to double check to see if we got that answer right by using our area for a trapezoid. Okay, so the area for a trapezoid we have already at the top of our page. Okay, I'm going to use just a slightly different form of it. So the area of a trapezoid is, and you're going to do this as well, 1/2 times h times a plus b. So if you take a look at the original one that we wrote down, and you can see how it was modified, multiplication and division can move around a little bit. So instead of dividing by 2, we're multiplying by 1/2. So we have 1/2 times a plus b times h, and because multiplication is commutative, you can kind of put those in any order that's convenient to you. Okay, so let's punch in what we know. We know the height of this thing is 16. And we know one of the bases. Do we know the top and the bottom base?
Yes.
How do we get the bottom base? Because it's
You
from here.
add 12, 24, and 4.
Alright, so we'll just, for B, I'll do a little side note here. B equals 24 plus 12 plus 4, which is 40. Okay, so let's sub those in. A is 24 plus B, which is 40. And now again, we're just using bed mass. What do I have to calculate first?
Brackets.
I need to take care of my brackets first. So I've got 1/2 times 16 times 64. Chuck that in the calculator,
64.
and you end up with, oh, divide by 2.
112
And our units.
centimeters.
Alright, so the area of the trapezoid is 512 centimeters squared, and of course that's the same as the area that we got the other way. Which way would you rather do it?
First way.
The second way.
Second way, definitely second way.
So again, when you're unfamiliar with things, yeah, they seem like, oh, that's hard. But look at the space that this took up. 3 steps, and we had it.
I know, I get
As
it.
compared to all this.
I just learned on the
So-
first one.
I'm just used to it. So
Yeah.
I'm used to
So
it.
the goal is to use the new things that make things
So you
easier.
want us to
So
do
this
that
will
big
get
round?
easier for you if you do it a bunch of times. Alright, example 1b asks us to find the perimeter of this stained glass window. So we're looking at the same diagram, but this time we're not filling in the area. This time we're just going around the whole window. Okay? The perimeter is the distance around an object. So I don't need to worry about the length of this and this, except that there are 2 unknown side lengths that I need. So we know this big length already. We said it was 40 centimeters. But don't I need this length over here, and I need this length over here. How can I find them?
Pythagorean.
That's right, I've got 2 right angle triangles here. So we can use one of the other tools in our toolbox, which is the Pythagorean theorem. I'm going to call this side C. I'm going to call this side D. Okay? Well, let's go ahead and calculate side length C. We know that C squared is going to be A squared plus B squared. Well, in this case, those 2 legs of the right angle triangle are 12 and 16. So we've got 12 squared plus 16 squared. So now what do I do? Do I just add 12 plus 16? I first have to square them. Okay. So who's got your calculator out? 12 squared is 144 and 256. Add those up and square root both sides. Alright, I'm going to add that to my diagram.
What were we just
Just figuring out the length of C.
Oh,
Now let's go ahead and figure out the length of D. So D squared is, somebody tell me what numbers are there?
16 and 4.
So finish out my sentence. D squared equals 16 squared plus 4 squared. Please copy it down properly. If you can't remember, then you need to write at the top of your sheet, A squared plus B squared equals C squared. Okay? Alright, 16 squared we just did in the problem above, so I can copy it down. It's 256. 4 squared is 16. Add those up. Take the square root of both sides.
About 16.5.
Yeah, round to the nearest centimeter. We're going to use 16. Right, is it 16.4? Something.
16.49.
Yeah, so 16.4. You look at the tenth of a centimeter, the first on the outside of the decimal, and round down. So D is 16 centimeters. Now what do we do to find the perimeter?
We add them.
Okay, perimeter equals, go just pick a side and go around. 20 plus 24 plus 16 plus 40. In your calculator? 100 what?
Centimeters.
Just that?
How come it's not centimeters squared?
It's not area.
It's not area, it's just a length. It's just if we detached all these sides and folded them flat and lined them up, it'd be 100 centimeters long. Okay, if you were a little ant and you were crawling along the edge, you would have crawled 100 centimeters by the time you got back home. Alright, so the perimeter of the stained glass window there is 100 centimeters. Okay, now it starts getting a little more fun. You can see your next diagram. Oh, you actually don't have a diagram, so let's draw one. Your diagram, grab a ruler. Your diagram is going to look like this. It's going to be like a long rectangular shape.
How big do you want this?
It should fit in that little space you have to the right of the words. Okay?
Wow.
Draw this straight across. Mark them as right angles. And the top of your diagram is actually going to be a semicircle. So do your best to draw a perfect circle in there. Okay? The base is 2.1 meters, and the length here on the side is 5.2 meters. And let's read. A hotel is remodeling its outdoor entrance area. The new design includes a tile walkway leading to a semicircle fountain. So this is some kind of fountain. Okay? A. We're going to first describe the steps that you would use to find the area of the walkway. Don't call it out. Think about it. There's kind of two main steps that we're going to take in order to get the area of the walkway. Remember, the walkway is just the area that's enclosed by this figure, okay, this composite figure. Think about how are we going to get the area of that shaded area. Test your answer with the person nearest you. Cubs, you're going to have to look back.
And then concave.
No, just the walkway.
Oh, okay, yeah.
I have no idea.
Yeah.
But my answer will be sufficient.
And then you just minus it.
Right, on here.
Maddie Mads, what do you think?
Okay, so we're gonna find the whole the area of the circle, and divide it in half, and then take it away from the rectangle.
Nice. So in order to do that, we first need to find the area of the rectangle, right? So we're going to first
We can't see.
find the area of the rectangle. Then subtract the area of the semicircle. So in that word semicircle, you're realizing that you're going to find the area of the circle and then cut it in half, right, to get the area of a semicircle. Okay. Well, B says, go ahead and do it. Calculate the area of the walkway, round to the nearest tenth of a square meter. Okay, so to 1 decimal place. So this is the answer to A. In B, we're actually solving it. So we said first we're going to solve the area of the rectangle. What should I write?
Area.
A equals A triangle rectangle. 2 point A length times width.
Alright, so just start off always by writing the formula that you're using. Do not plug in the numbers right off the bat, okay? It leaves you very susceptible to making errors, and it makes it a lot harder for anyone else to see what you've done, including yourself. If there's a multi-step problem and you haven't labeled each part of your problem, it's going to be really hard for you to go back and be like, oh, I still need that number, I need that number, I need that number to add up at the end, or something like that. Okay, so write it like this. Good. Now we plug in our numbers. What are our numbers?
2.1 times 2.5.
2.1 and 5.2. which is
10.9.
2.
yeah. Hold on, let's not round too early. Okay. So at the end, our final answer is going to be rounded. But if we round too early, we're going to lose important information. We don't want to do that. So keep your 2 decimal places for now. And what's the next thing that we needed to do?
Meters squared.
Sure, you can put that in there. You don't.
Now we do the area of the circle.
Now we do the area of the circle. All right. And actually, do you want to do the area of the circle, or do you want to change the formula just to make it a semicircle right away?
No.
Let's change the formula.
Let's change the
I
formula.
love
Watch this.
doing this stuff.
So here's your semicircle.
Maybe you should become a math teacher.
No.
So sorry, what's the formula for the area of a circle?
Pi squared.
Pi
But then you're
r
gonna have to
squared.
divide by 2.
So if I did 1/2 of that, we'd be good to go.
It's half pi r.
Okay.
Half pi r.
So you're just taking half of pi r squared.
Yep.
All right. Let's plug in what we know. What's the radius of our circle? Oh, this is a bit hard. So we need to note. Let's make a little note. Radius equals 2.1 divided by 2,
How do we know that though?
which is 1.05, because the diameter of the circle is 2.1 meters. Okay, all the way across the circle is 2.1 meters. So the radius must be 1.05 meters. So let's sub that in for our radius, and we're going to square that thing. And we're following the order of operations, our rules of algebra. So what do we need to do first?
Brackets, exponents.
So our bracket is already simplified to 1.05. We need to do 1.05 squared, which is
3.
1.02.
yeah?
Yep.
Okay. And then you can put that really in the calculator altogether. If you do, if you just leave your answer in there, you hit times pi, hit enter, hit divided by 2, it will come out very nicely. Okay?
What's pi? What's enter?
Another way to do that on your calculator, enter is just equals. Okay? So if
Divided
you
by
did
2?
this, if you did 1.05,
1.6.
Aha!
5.
If you round.
Times
mm,
2. Times 2?
I don't think.
so hold on guys, hold on. So you're going to punch 1, you're going to punch decimal, you're going to punch 0, you're going to punch 5, you're going to punch this x squared button. Okay? That will probably give you a result right away. Or do you still have to hit equals?
Nope, I don't.
Okay, so that gives you a result right away. Then you
1.1.
leave that answer there. You hit times pi,
This is not.
and then you hit times, well, let's do divided by. Divided by 2, and then you hit your equals button.
1.73.
Alright, there we go. 1.73.
Should we do approximately? Oh, you did.
Yep, good job. Okay, so what's our final step? We have the area of the semicircle and the area of the rectangle. Are we going to add them up?
No, we have that minus.
So the
Subtract.
area of the walkway is equal to, always write what you're going to do, right? We're going to take the area of our rectangle and subtract the area of our semicircle. So here we go. We've got 10.92 minus 1.73. And in our calculator, that's going to give us
9.19.
9.19. And what did we have to do in our final answer? It said round to the nearest tenth of a square meter. The I didn't round this one though.
No, but the semicircle.
He
Yeah,
did.
it's there.
No.
Yeah, when you subtract
Then it rounds to the
10.92 minus.
So I could put a dot here, here, and here.
Do you have to? Or?
Nope.
Okay.
You don't have
Okay, the area of the walkway is approximately, and now here's where I'm going to round to my nearest tenth, 9.2 meters squared. Everyone good on this? We'll run through it quick. All we did, we calculated the area of the rectangle. We calculated the area of a semicircle. We used the area formula for a circle and cut it in half. And then we took the area of a rectangle, subtracted the area of the semicircle, and that would be leaving us with the shaded region there,
Where'd you
the
get
area
1.5
of the
from?
walkway. Okay? 1.05.
Yeah.
That's the radius of the semicircle. Because we needed r
Yeah.
in order to calculate it using our formula. So r is half of the diameter, which was 2.1, so 1.05. All right, I'm going to clear this, and we're going to read number C for ourselves. Number C says, the walkway will have a border in a different color of tile, and we're going to calculate the perimeter in order to figure out how much of this tile they are going to need. All right, so let's talk about the perimeter. How am I going to calculate it?
Okay, I just have a question for the area of the circle.
Okay, first step in calculating the perimeter.
You add, since you divided 2.1 to the thingamajiggy,
Well, let's talk about it without numbers first.
you just add all the sides together.
So what describe the sides to me? The perimeter includes 3 sides of the rectangle. The perimeter includes 3 sides of the rectangle, and what else?
And one
Radius is semicircle.
semicircle.
And a semicircular arc. So an arc is an arc is a curve along a circle, so it's a part of the outside of the circle. So this arc consists of half the circle. Okay, you can have an arc that's only like less of a circle. Okay, like a smaller sector of the circle. There's lots of different words that use in describing that. But anyways, this arc is a semicircular arc. Okay? So, what do we want to do first?
Add up the perimeter.
Yeah, well, we already have the side lengths of these 3, right? So why don't we first calculate, stick with it, guys. First calculate the length of the arc. 8RC, not 8RK. Well, how am I going to do that? What's the length of a circle? The length around a circle. What's that? What word do we use?
That
For the length around a
radius.
circle.
Circumference.
The circumference. So I actually need half the circumference of the circle with a radius of 1.05. Okay?
we learned,
So we can use that there.
wasn't it CR divided
So you find the circumference.
So we've got
divided by 2 and
the
add the
length.
side.
I'm going to call the length of this arc L. Okay, so the length is equal to, and circumference is what? Yeah, 2 pi r or pi d. So we're taking half of that. Either way, 2 pi r is a really good way to do it because you're taking 1/2 of 2 pi r. Well, if you have the number 2 and you divide it in half, you just get 1. So these guys just kind of cancel out.
Peace out.
And the length of this
What?
arc is just pi times r. Okay?
How did that happen?
Yeah, how did that?
Math.
So
2
half times
2 divided by 2.
1.
Or half of 2.
Okay.
Okay. So here we have pi times r. R we decided is 1.05. We did that in our previous section. Go ahead and use your calculator to do that.
.329.
So we round to the nearest tenth. 3.3 meters. 3.3 meters.
Is it square?
What did we get? Did we get an area or did we get a length? We got a length, so it's not squared. Now the perimeter of the walkway is L, which was the length of our arc, plus the 3 sides. Okay? 3 sides of rectangle. So let's put all those in there. L is 3.3. The 3 sides of the rectangle are what?
5.2.
5.2.
Good, 2.1.
I said 3 sides. You only gave me 2 numbers.
And 2, 5.2.
Okay, so we need another 5.2. Okay, we've got this 5.2. We also have this 5.2. Okay? And this is 2.1. Excellent. Add them up. Carefully. Make sure your calculator actually gets all the things that you punch in.
15.6.
Yeah, 15.8.
6.
8.
Oh, we did the deciding factor.
6.
8.
6.
8.
8.
No fair.
Alright, the perimeter of the walkway. Finish off with the sentence. The perimeter of the walkway is about or approximately 15.8 meters. Some of the key concepts. A composite shape, a composite figure, is made up of more than one simple figure. To determine the total area, you add or subtract the areas of the figures that make up the composite figure. In order to determine the perimeter of a composite figure, you need the distance around the whole figure. So okie dokie, your practice problems are on the bottom of that page. They're from page 410, numbers 1 through 11, and page 413, numbers 1 through 8 and 10. Okay?